Okay, so the percent we figured out with the percent yield was how much we could make if we mixed chemicals. Percent composition is the opposite. Instead of talking about how much you can make, it's about how much there is. Okay? So when you have a chemical, there's going to be different percentage of different elements. That's percent composition. Okay? But so the percent of things it's composed of. Okay? But percent composition is like all percents. All percents are the same. The part compared to the whole times 100%. Okay. So in order to figure out a percent, I'm going to need to know the part, the whole, right? So I got to figure out the mass of each component. So there's going to be a percent for each element that's in there. And then I have to divide by the total mass. I mean, when you calculate percent on your grades, you say the part I got correct out of what I could have got totally tells me how many percent I got. If it were out of 100, that's how much I'd get. So, find the percent composition if you had a compound and you tore it apart and it was 29 grams of silver and 4.30 grams of sulfur. What would the percent composition of that substance be? Okay, so how are we going to do this? Well, I know the percent that is silver is going to equal the grams of silver over the total grams times 100%. And the grams of silver, they told me, was 29.0. How much does the whole compound weigh? Well, it's made up of silver and sulfur, so it's 29.0 grams plus 4.30 grams, which is 33.3 grams. So the whole thing weighs 33.3 grams. And I can either do that division or I can say to myself, hey, I probably just multiply by 3 and get 60 and 27, 87. But let's push the buttons. 29 divided by 33.3 is 87.1%, 3 sig figs. 29.0 had 3 sig figs, 33.3 had 3 sig figs. Hundreds of definition. Okay. What's the percent that is sulfur? Well, it's the grams of sulfur divided by the total grams. And the grams of sulfur is 4.30 grams. The total grams was 33.3 grams. The part divided by the whole times 100% equals push the buttons on your calculator. 4.3 divided by 33.3 times 100 And it shouldn't surprise you that it's 12.9%. Is that pretty obvious that it had to be 12.9? Why was it obvious that it had to be 12.9? Because it had to add up to 100. So if 87% is silver, the rest has to be sulfur. Okay? So that means in order to do this, what they did is they took a compound and they tore it apart and see how much the silver and the sulfur weighed. That's the experiment they did. Okay? Now, oftentimes we don't want to do an experiment, but we can get the percent composition straight from the formula. Okay? Yep. We can get it straight from the formula. And here's the whole secret. We need to know how much the part weighs and how much the whole thing weighs. Does the percent change if I have different amounts of stuff? Okay. If I had had that same compound and I'd torn apart twice as much when it was silver and sulfur, would I have gotten a different ratio? No, the ratio is always going to be the same, right? So every compound is going to have a specific ratio. Hey, that sounds like the law of definite proportions. Okay? And if you know the formula, you can figure out the percentage just assuming that you have 1 mole. Because if I ask you how heavy 1 mole of a compound is, can you do that? If I ask you how heavy 1 mole of H2O was, could you figure that out? And think about what you would do to figure that out. You would figure out that how heavy the hydrogen was and how heavy the oxygen was, and then add them together. So you have all the parts you need: the hydrogen, the oxygen, and the total. So in the process of figuring out the molar mass, you figure out all the numbers you need for percent composition. So there's a connection between the formula and the percent composition. Today, we're learning how to turn the formula into the percent composition. Then we're going to learn how to turn the percent composition back into the formula, because things go both ways. Okay? So, calculate the percent composition of C2H4. So we start off just by calculating how heavy 1 mole is. So that's going to be 2 carbons and 4 hydrogens. The carbon weighs 12.01 grams on the periodic table. The hydrogen weighs 1.01 grams. So that means I have 24.02 grams of carbon and 4.04 grams of hydrogen. That gives me to a total of 28.06 grams. Anything earth-shattering there? Any new math there? Here's the new math. We got all the numbers we need now. If I want the percent that's carbon, I need the grams of carbon over the total grams. Well, the grams of carbon was 24.02. The total grams was 28.06. I multiply that by 100%, and 24.02 divided by 28.06 equals 85.60% carbon. And the percent that's hydrogen is 4.04 grams of hydrogen out of 28.06 grams times 100% equals 4.04 divided by 28.06 times 100 is 14.4% hydrogen. Oh, isn't it 40, Mr. Green? No, it's not, because 4.04 only has 3 sig figs. Yeah.
So if we already found, for example, the percent of carbon, can we just like subtract?
Oh, it'll get you the right answer if you did the percent carbon right. Well, by figuring them both out, you know you didn't make a silly mistake. Right? Can you see how that's a built-in check for you right there? I'm okay if you subtract, but you're taking the risk. I can't argue with your math. Now, if there's 3 different elements, you got to do it 3 different times, so you'd have to figure out 2 and add them up and then subtract, and that wouldn't be worth your while anyway. Does that make sense? Okay. So what's the percent composition of aluminum oxide? So first we have to write the formula for aluminum oxide. If you write the wrong formula, you'll get the wrong percentages. Aluminum, oxygen, Al's in the 3 plus column, O's in the 2 minus, so it's got to be Al2O3. So I've got 2 Al's and 3 O's. Two Al's and 3 O's. Oops. And then the aluminum on my periodic table is 26.98 grams. The oxygen is 16.00 grams. So that is 53.96 grams of aluminum and 48.00 grams of oxygen. Altogether, that adds up to 101.96 grams altogether. So it's just like figuring out regular molar mass. Now we take those pieces and figure out percent. So the percent that's aluminum is 53.96 grams of aluminum out of 101.96 grams total times 100% equals 53.96 divided by 101.96 equals 52.92%. And the percent that's oxygen is 48.00 grams of oxygen out of that 101.96 grams total times 100%. So 48 divided by 101.96 with 4 sig figs is 47.08%. So my answer is 52.92% aluminum, 47.08% oxygen. Really hugely different than what you've done with percentages in the past? Nah, same percentages. Why do this? Well, here's the real reason. Okay, when you go to a mine for aluminum, they don't dig aluminum out of the ground. Okay, they dig aluminum oxide out of the ground. So when you dig that aluminum oxide, you're going to need to know how much aluminum's in that aluminum oxide. Well, now we know that 52.92% of it's aluminum. So that by the amount of ore, it's called bauxite, B-A-U-X-I-T-E, bauxite is the ore. By how much ore you have, you can figure out how much aluminum is going to be there before you take it apart. Because what they have to do is that aluminum oxide have to use electricity to tear those two aluminum oxides away from each other. Okay. So, you can change percentages into mass by multiplying the percent by the total mass to find out the mass of that component. This is the equivalent of if you got 80% on a test and the test was worth 20 points, what was your score? 16. So you took 80% of that 20, right? Well, that's what we have to do here. Okay? If you had 450 grams of aluminum oxide, how much aluminum would you have? Well, this is easier because we've already done the hard work. We already figured out the percentages. So I know it is what, 52.92% aluminum, right? Equals X over 450 grams times 100%. That's how the problem is really set up. How do we usually use it? We usually move the decimal place over twice and then multiply by the total, which is what this math tells you to do. Move the decimal place over twice, divide both sides by 100. So I get 0.5298, 5292. Okay, and my percents are gone, I don't have any units. That's going to be X over 450. So if I multiply 450 grams to divide both sides, I end up with move the decimal place over twice times the total, which gets me that X is equal to 0.5292 times 450 equals 240 grams. So, well, my calculator gives me 238, Mr. Green. How many sig figs in 450? 2. And I could picture a balance where it was every 100 grams. That's a reasonable picture. Fact is, if I'm digging aluminum ore out of the ground, I'm probably working in tons, not grams. But it would work in tons too. I mean, you say, well, when I said this is normal practice, when I worked in the lab in a quarry, what we were mining was calcium sulfate. Okay? And we did a test to find the percent that was sulfur, because sulfur would only show up in the calcium sulfate. So that you could tell how pure your rock was by how much sulfur there was. So we do reactions to get the sulfur by itself, and then see how much of it was in my whole sample. So because from that percentage, I can figure out how pure my calcium sulfate was. Because when you're running a big old crane or a big scooper, you can't always get just the rock you want. There's going to be some dirt in there too. And we guaranteed our customers 93% pure. So we had to check that it was 93% pure. And that's one of the ways we checked, was to see how much sulfur there was. Okay, so one last example. Calculate the percent carbon in cadaverine, C5H14N2. It's what gives rotting meat its smell and attracts the flies. That's why it's called cadaverine. You want to draw flies? Spread some of this around. Okay. If you were successful at that, you should have gotten B. Should have gotten B, 58.8 with 3 sig figs. I got 58.75, I think. Okay. So, really hard? Nah. Tedious? Yes. Okay. But we need that connection between percents and formulas so we can go backwards on Friday when we go from formulas, before we go from percents right to formulas. So we're going to take from formulas to percents today, and we'll do the other way on Friday. Okay. So now we actually talk about the reactions they do to test see what chemicals really are. Part of its precipitation, part of its composition,